Okay, I'll call the meeting to order. I'm on Zoom, and so this is an opportunity to convene the Sewer Commission meeting in an open session at the Wacoit Meeting Room at the Mashpee Town Hall. And we can have let's all stand to do the Pledge of Allegiance. I can't see the flag, so I need to have somebody take that part over.
Sure. Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, could we then observe a moment of silence and have an opportunity to think about all of the difficulty as people are going through floods and whatever in California and other places in the world?
Thank you.
Okay, are there any members in the audience that want to share something, anything at all with the Sewer Commission?
Doesn't appear to be, Meredith. We should welcome Aaron Copeland.
Absolutely. I mean, that would be that would be even before the minutes. So,
Okay.
Erin, I look forward to meeting you in person when I come back into town.
Thank you, Meredith.
So welcome to the Sewer Commission, Erin Copeland.
Thank you. Happy to be here. I'm looking forward to meeting you in person.
Wonderful. We are now at full strength with 7 members of the Sewer Commission.
Great.
Okay, is there, so I'd like to then raise the issue of the minutes from the last meeting that was held on March 9th. Is there any discussion?
Madam Chairman, I move that they be approved as written.
Is there a second?
I'll second it. Catherine?
Okay, excellent. So minutes are accepted and seconded from the March 9th meeting. So also, if we look at the agenda, there is no old business to bring up. The new business is to have our interim engineer, Mr. Ray Jack, give a monthly sewer project construction update. Mr. Ray Jack, you're on, please.
Thank you, Madam Chairman. Can you see the screen?
Yes.
Okay.
I mean, I can see you, but I don't see the screen, the video screen.
Okay, can you hold on just a sec? I'm going to try to get the share screen up, hopefully. Uh-oh. The mouse won't even go on it. Great. Okay, we'll try this one from scratch then.
I can hear you if it's too difficult to do that. So we could go with my hearing the audio and then you could present to the rest of the commission.
Okay.
I think if you click on her picture, you'll get a share screen.
The problem was getting the mouse to move.
Oh, that I can.
Cheese, maybe?
We need a cat.
A piece of cheese?
Unfortunately, I can't get to the share screen on this.
Is it a touch? Can you touch your computer screen?
Nuts. Oh, well.
The savior.
Help is on the way.
What do we got here? Let's see. Click this. This is going to be video. Zoom this down.
Yeah, the mouse doesn't seem to want to go there.
Just drop that. Zoom. Yeah, this should be big.
Okay, that might do it. Oh,
Close, stop video, remove. Where are the controls? Exit. Okay.
okay.
Just share the screen.
Any questions so far?
And then go back to your PowerPoint, which is here.
Good. Can you see that now?
Yes, I am able to see it. Thank you.
Okay, good afternoon, everyone. This actually won't be too long of an update. I've tried to make it both informational as well as historical, or I should say educational, okay? So you'll have to try to bear with me a little bit. But anyway, it's been a month, so normally these presentations would be the third week of the month because it takes that long to get all the information together, all the invoices, so you have something that is statistically correct. So this is the Water Resource Recovery Facility, WRRF. So this is actually the main plant up at the transfer station. The original contract cost was $27.9 million. The adjusted contract value is $29.5. That's because we add in the change order at the bottom of the screen of 1.6. That allowed to be able to put in the carbon scrubber for odor control at the plant, as well as the additional tankage. So the plant will be constructed with all of its available volume for tanks on there. It's about 6.5% with respect to percent complete based on cost, all right, based on value, as opposed to based on time. This is the cash flow chart, as I had indicated previously, and this is primarily for Erin, that when I put a chart like this together, you have three lines up there. One's going to be the original budget, which in this case is blue. The adjusted budget is going to, it'll include any change orders as the project moves forward. Then you have the actual cumulative expenses. This is over the entire 2-year project timeline. So the estimated values for the $27 million and the $29 million are spaced out based on when they actually expect to be able to be at a given point on the project. So the three lines, theoretically, should usually try to stay together. We're going to have one difference today, and I'll show you that one. So then this collection system north contract. So the original value is $5,024,000. Adjusted value is the same because we haven't had any change orders yet. They've been doing a lot of good work up there. So the project, based on value, is considered over a quarter complete at this point, and you'll see as I start moving through some of these slides why that is. The lines deviate here, all right, but only because it's a good thing in this case that they're moving that fast, all right? So they're ahead of the curve of where they would normally be contractually on this. So that's the one time I can say that being ahead of it is a good thing.
Can I ask a question? When you say you're ahead, what percentage did you think would be complete at this stage? You're saying it's 27% is complete?
Right.
What did we expect? Like, was it, you were expecting 15%
Yes.
completion at this stage?
Yes, it would have been down around 15%.
Okay.
So, and you'll see that on the other contract. So there's the collection system south, or contract 3. Original value, $9.8 million. Actual value is $9.8 million. It's only 8% complete, but they have made very good progress in this last month. So far, we paid out $788,000 as of the end of February. That's not March, as February. So here's the cash flow for that project. You can see the lines are running pretty close together. So this is the project area north. This is a newer map. So we're going to have a north and a south map now instead of one map for the entire area. I put the legend on the left-hand side. So when you see the yellow lines, those are mains that are already installed and completed. Green lines represent the mains that have to be installed. So you can see up here you have, in this area here, you have Drew and Butler that are remaining to be done. Blue lines represent pressure mains. You have a couple of small ones here, over here at Sea Oaks, and then down here you have the force mains that are coming up from the southern area. The red represents the current work area, meaning as of now, March, even though this is a February report. So there's a lot of work that has already been done throughout this area. The Sea Oaks mains are complete, they are in, but yet they still have work to do with respect to manhole covers, which I'll be talking about later, and or service installations in certain areas. So Sea Oaks, the main is in, but the services are not yet. Project area south, got the same legend. So here what you're looking at, this is Quiniquisette going across here. Then we have Orchard going up here. Simons Narrows, this short piece down here. So this was the terminus or the end of the project main right there. Came up to Mashpee Neck Road here. Lift station located right where that little black dot is. And this main is already installed. As of today, they are up at Quiniquisette as of today. So they made very good progress, but you can see a lot of green up there, Orchard, Quiniquisette, and all of the shipwreck roads, okay, still have to get done. And I do love that. Ship's anchor, ship's compass, ship's rudder, and then you got shipwreck, you know, at the very end. I'll never get over that. So, up at the plant, you can see it's a little bit different. Last time that I showed a slide like this, it was really a big sand pit, all right, play box. But you can see that they've gotten a substantial amount of work done. This is not all the underground piping, but this is the underground drainage piping. Then they have a bed of stone here, and across here you can see wood and steel forms going around the peripheral area. This is the process building, so they haven't laid the concrete in there yet, but as you'll see on another slide, the equalization tanks, they actually poured concrete today. So they're making very good progress at the plant. So on the left screen here, this is the equalization tanks. They have the rebar and the forms are in place, and they poured concrete in that today, and that was, I believe, 1.5 feet, 1 foot 6 inches of concrete for the base slab, and I think the process building is going to be 1 4 inches, if I'm not mistaken. They did bring their crane in. This crane has less than 100 hours on the hour meter on that thing. It's brand new. The tires just got dirty, but it's a beautiful piece of equipment. Right now they're using it to be able to pour concrete, as well as to move bundles of rebar, which are very heavy, down into the work areas down there. And they'll also use it for transporting materials in or out of the pit itself. So, for the collection system north, for Carlton, Swain, and Sewell, all of the manhole frames and covers have been installed. I'll be talking about them in a minute. The 8-inch mains are already in Sea Oaks, as well as the 2-inch low pressure mains. They were installed this week. The picture on the right is just showing a manhole installation. I'll be talking actually quite a bit more about some of that today. You can see the green SDR-35 sewer pipe that was placed into the manhole, and then there's a rubber gasket that you can't see. It's in this vicinity here where they seal that opening. So this was just the first base of the manhole that was installed here. Collection system south, the main is in on Simons Narrows, and main is in on Mashpee Neck Road from Simons all the way to Quiniquisette, and that's not one main, it's 2 mains. So here on the right, you have the 8-inch gravity main, and this is a service fitting for a home. And then this main over here is SDR 21. That is the force main that runs the length of Mashpee Neck Road coming from the lift station. So because there are two mains in the ground, these are two tapes that are placed about 1.5 to 2 feet below the surface. They're magnetic tapes, so they're capable of being traced by an electronic detector. So one's over the gravity main and one is over the force main. And if anybody digs there that doesn't try to detect it and they encounter that, it has written instructions on it. It's telling you it's right above a sewer main. All right, so it's hard to miss. So this is the educational portion of today's presentation. I was thinking to bring the community up to speed. You're building a sewer system, spending money on it. What are you building? It's got a lot of moving parts and a lot of parts that don't move. Manholes don't move, they don't go anywhere, all right? But contrary to the name, and I realize that to be politically correct, the name probably has to change. It's not a manhole. A man does not live inside of it, all right? So everybody has seen these, they're everywhere. You see them all over the road, you drive over them every day, and nobody knows why they're there or what they do. So that's today's goal. So what you're seeing on the left is just the cover. What you're seeing on the right is a framing cover, all right? So you have to have a frame that supports the cover, and then the frame goes on top of the manhole structure, and you have a bricklaying crew that comes in and facilitates that structure going on there. So for some of them other roads we talked about, that's what happens after the fact. The main and manholes go in, but the manholes are buried. Then a crew has to come in, dig up the top, and put these structures on it. So this is a map, and it's a map of a sewer system and a water system. The blue lines represent water mains, the brown lines represent sewer mains, and the dots represent manholes. You need to become familiar with this because you're going to have one of these. Once the system is complete, through the town's GIS system, maps like this will be developed. They're very, very technical. They contain a lot of database information behind it for every piece of pipe and every manhole and every service connection, so that you can get within 6 inches of any of those components at any future time. This one's fairly basic. It's just showing you the main and the manhole. A lot of maps, you can show the size of the main, what type of main it is, whether it's a force main or a gravity main. And you can also show the direction of flow for the mains through the manholes, okay, give you a better picture of what's going on overall. But you will need to become familiar with it because you're going to have one designed for you. So why do we put a manhole in anyway? All right. From a construction perspective, anytime a pipe changes in elevation from high to low or low to high, you have to have a manhole, all right, because you can't deflect the pipe. You can't bend the pipe. So it can't go up or down, and it can't go left and right. So the only way to make those changes in the ground is to put in a manhole. So if the elevation and or the direction of the pipe is going to change, like if you're going around a bend, that's where you'll usually see more than one manhole going around the bend. It facilitates straight runs of pipe, but then they hit a manhole, and then the manhole allows it to turn. And or to connect intersections. So when you're connecting an intersection, it could be 3 or more ports at the bottom of that manhole, because you got a main that's going through the manhole for the road itself, and then you have to have another opening or port for the connecting street that's going to come into that manhole. So what do we use them for, though, after the fact? That's why they were installed to begin with, but there are uses for them after the fact. You need to have access to the main. All right, you put in a sewer system below ground, various pipe sizes, and eventually, sooner or later, you need to get to that pipe. The manhole facilitates that without digging the road. Sewer main cleaning is probably the biggest reason down the road that you need to have access to the main. Venting and or overflow, those are kind of in the old days. In the old days, you would see a manhole, sewer manhole specifically, sanitary sewer manhole, they would have holes in the top of it. So I'm sure you've seen them in some cities. Those holes facilitated venting of sewer gases in a manhole. And or it can serve as an overflow point if the main ever backs up. And then air and or sewage sampling. So for air sampling, that deals with the quality of the air. and it becomes a safety issue from a entry point of view. And sewage sampling, there may be time in industrial areas where you want to take a sample and send it off to a lab. You can open a manhole, access it from the surface, grab a sample, send it off to the lab, find out what's in that wastewater. So this is what a manhole actually looks like in this pictograph. And I'll start down here at the bottom because that's the way we build them, from the bottom up. So you have what the bottom of a pipe is called an invert, all right? So you have the top of a pipe and the bottom of a pipe. There are two different measurements. So you always want to go by the bottom value because that's where the gravity flow is going to be based on. Now, a bench is constructed around it, and this particular diagram doesn't show it very well at all, but I do have a couple photos that you'll see what I'm talking about. So you have a pipe coming in, you have a pipe going out. The pipe doesn't go through the manhole. It comes in, it's cut off, goes out, it's cut off. So you have to build something inside so the water's not just flowing indiscriminately into the manhole and then filling up and flowing out, all right? So you literally, at the invert level, you have to build that invert with bricks, all right, to channel the flow through the manhole. So then we come up to the barrel section. You can have multiple barrel sections, which we do on this project. You'll put the base section in first. You could have other barrel sections when you're on a deep manhole to come up to a higher elevation. And then the last section that's usually put on is going to be the cone section. The cone section, that's an elliptical cone. And the reason being, where you can see the manhole steps. In the old days, they actually used to put not a concentric one, but the manhole itself was centered over the whole manhole. So if you wanted to get in there, once you got in, you had to actually move your body over to the steps in order to get in and out. Very, very dangerous. So now with concentric manholes, that hole or opening is right above the steps. So as soon as you open it, regardless of the diameter of the main, you're looking at the steps. Then a manhole ring and cover go on top of that. These are up by Butler. I took these shots the other day so you can see multiple sections of a manhole. You can see the concentric manhole there on the left and the right. The right one was actually assembled above ground. It's not fully assembled, but that's what it would look like if it was. And then you can always tell which one is the base part of the manhole as opposed to a cone structure because it has a lip around it. So these are prefabricated by a concrete firm and then delivered on site. So they're very specific for a very specific location on site as far as where the holes are, what degree of deflection those holes have if a road doesn't line up. So these are constructed based on the design drawings for the system. So this is how they're putting one in. What you see here is a guy down in a hole, and what he's doing, he's actually drawing a red line. So this here is a stick that he has in his hand with a paint can on the end of it, and he's going to draw a red line on this stone that was placed down there as a base for the manhole. He'll draw this red line very accurately. That's what this device here is. This tells him exactly what depth to put that sewer base so that it's always correct. And then they will place the manhole where he painted that red circle down at the bottom. This is the upper section or the last piece that would go on a manhole. So you can see there's a hole there in the middle of it, or not in the middle, offset, right over where the manhole steps would be. You have two little cables, steel cables here, one here and one here. Those are for lifting. After they get it in place, they saw cut them off. And then after this, since this is the last piece that goes on, a crew will come in and they will build the base for the frame and cover out of brick and mortar. So this is showing a similar manhole where they're preparing for testing on the manhole. So what they have here, that opening there is actually right here. And they put an insert in there with a bladder around the end of it to seal that top opening. And then they have hoses connected to it. They have air pumps associated with it. And they're testing the main for tightness to to make sure that it doesn't leak. So this crew is doing this as they're putting these manholes in, which is great. So you know that the integrity of the manhole is going to be good over time. This is that top section I referred to where you have masons come in. So there's a specialized crew that comes in and does this. So you can't see the top of the manhole actually, because that's down here. But what they did is they built this out of brick and mortar on the top. Then the manhole frame is under here, and that's the manhole cover there. And they have to do it this way because no matter how accurate you are with the actual manhole sections, you've got to be able to make a final adjustment for exactly where that road grade is going to be. Otherwise, manhole's going to be too low, too high, all right? So even if you see them out in the system, and if you drive around, you will see this, some of them are raised a little bit. That means that the final elevation of the road after the project's done is going to be at the elevation where you see the manhole. So that's why it's raised a little bit, and they build an asphalt ramp around it to facilitate, not damaging vehicles. So this is after they were done with that, and this is just shot in the manhole, so you can't see much, but you can see one of the steps right here, which is showing you how easily accessible they are. But there's also something in the bottom that you can't see. Where is it? Okay, so this is the invert area right here, and this is Yardom Drive. So this was put in on Simon's Narrows, and this is Yardom Drive, the main coming in from Yardom on this side here. And you see how they slope and bend. It's a very soft bend, all right, so that it doesn't clog up try to maintain a uniform, consistent flow. This is known as a bench over here, up here, and down here. So what happens is you see the diameter of the pipe. So in this case, it's 8 inches, all right? But about half of that diameter, coming up 4 inches to 6 inches, is going to be this wall. Same thing with this wall here, and then it forms literally a channel to control the flow of the wastewater coming through the main. Generally speaking, the wastewater, even at higher flows, is supposed to stay in the channel. If it overflows for whatever reason, these benches here are sloped back into that channel, all right, so that the water, as it recedes, will flow back into the channel and won't sit up on top of that, and it can carry any solids with it when it does it. And this is just showing you with street level how the manhole was done, and in this case, it's pretty much matching the elevation of the street. I know it's difficult to see in that photo, but it means that for that particular application, the elevation of the street is going to be the same elevation as that manhole. I know you thought we were done. No. So FOG, in this case, it's an acronym that is a technical acronym within the wastewater industry, and it stands for fats, oils, and grease. Okay? So it's not the fog that you're used to. Fats, primarily from meats, can cause this, and this is at your drain level. So this is what a sewer S-trap would look like, all right, when it starts clogging up with grease. Then you have oils, either fryer oil and or cooking oils, that a lot of people will put into their disposal. What they should do when you have this, you should actually put it in your trash can, all right, and or try to turn it into compost. But right next to that, that's not in her kitchen, all right? This may be. But this right here would be the main, and what starts happening to a main over time when you put fats, oils, and grease in there. Then you have grease and baking, usually has a lot of grease. My recommendation to people for any and all of this, when possible, drain it off into some kind of container. You can keep it under the sink, old coffee can, whatever the case may be, but do not put it in the drain. If you do, over time, it does become problematic. And this last one, I know it doesn't seem to have anything to do with a sewer, but it actually does. That dog was rescued from a sewer because he fell into an open drain. And Roto-Rooter got him out, okay? But these kind of things do happen. You hear about kids falling in, things like that. So here's a couple examples of issues that occur more frequently than we would like to think. One of the reasons why you're not supposed to put trees over sewers is on the left. Those are tree roots. And what will happen is a tree root starts out about as big as a human hair. And once it finds an opening, and for just about any sewer main, you can always get into it. All right, whether it's got a gasketed joint, or in the old days, they used to use cement on some of the clay pipes. But either way, once that fiber gets in there, it's going to grow. And in the sewer, it's happy and healthy. It's got all the nutrients it needs, okay? So it will grow rapidly, and when it does, it will clog that sewer. On the right is a grease clog. And SDR35 pipe up here is what this is. That's what we are installing. So the fact that they're a plastic type of pipe does not mean that it inhibits clogging from grease. So what does that bring you to? Now you got to clean it. This is a vehicle that is utilized specifically for cleaning sewers. And you can see the man standing up there. In this case, by modern standards, a man does not have to go down into that hole anymore. All right, you can do virtually everything from above grade. And safety is the primary reason for that. We'll get into that in a little bit. But this truck here is called a Vactor truck, and they have different brand names for them. But on the back of the truck, back here, you can see a tank, and it's a fairly large tank. This is a boom with a hose inside of it, and it's vacuuming out anything that's inside the manhole. And whatever it vacuums out, it puts into that tank. And then they can, on the back of the tank, it has basically a tailgate assembly. They can open it, dump it wherever they need to. On the front of the truck is probably one of the most important pieces of equipment, and that's this hose reel. This is a high pressure hose reel, and that can go probably well over 1,000 feet, but you normally don't want to go that far to begin with. There are fittings, cleaning devices to go on the end of that hose, all right? So it gets lowered down into the manhole. That does get done from above. There's a guide bar that can make you put that hose from the top. You can make it put it right into the sewer main. But this is for cleaning. So it has its own water, just like a fire truck carries a couple thousand gallons. This carries its own water supply to facilitate that hose. So this is one of the heads that they might put on it. They have different degrees of deflection to control the angle of the flow behind it, because the bigger the main, the less of an angle you want in order to be able to have it expand out further and fill the main. Then it has a jet or multiple jets on the front of it to start breaking into or through a clog. And this would be an example of one in action inside of a main. So you can see that it kind of centers itself within the main in order to be able to properly clean it. These are called air bladder plugs. There are various sizes, and that's how you stop a main. Literally, they're big stoppers or plugs that you put into a main. Here on the right-hand side, on the right-hand side, you can see he's using an aluminum tube to insert the plug into this side of the main here. What's not shown and should be on here is an air hose, because once you insert it like this, once it gets in, then you turn on the air, you blow it up, it expands, it closes off the main and plugs it. And it's important to do that when you're cleaning a main, because now in this case, the cleaning would occur over here. That's where the cleaning hose would go. But once that goes up and starts cleaning the main, you don't want that debris traveling down to the next main. So this stops it in the manhole, therefore it can get sucked out. This is what I was getting to with all that. You own a sewer system, you're going to own a confined space program. What is it? By definition, it means it has a limited means of ingress or egress and a known potential hazard associated with it. So that generally means whatever structure you're talking about is one way in, one way out. All right? So it's intrinsically dangerous if there's a hazard associated in that structure. Manholes fall into this category. So hazards could be electrical. Sewer manholes normally don't have electrical components in them, all right, but electrical manholes do. Chemical, that can be associated with sewer. Atmospheric, definitely associated with sewer, and I'll get into that a little bit too. And of course, some of these manholes are relatively deep, It's always a fall hazard, so you have to have fall protection. To enter a manhole by modern standards is a minimum of a two-man job. By OSHA standards, they would characterize it as 3, but the difference here is that as long as the attendant is duly trained to be an attendant and a supervisor, you can do it with 2 men. But it takes one that's trained as an entrant to go in, and then one has to stay outside all the time in case something happens. A tri-detector, it's a device, electrical device that you lower down into a manhole, and it does 3 tests: combustibles, toxics, and the oxygen level, right? So combustibles, you could have methane gas in a sewer. There are other gases that develop as a result of decomposition of organic matter. Hydrogen sulfide would be one. That doesn't fall into the combustible category, will be in the toxic category. But it'll give you readouts of what these gases are. And one of the ones that's actually more important right here is this one, under the O2 level. Every breath you take, most people aren't aware, is 78% nitrogen. Figure we're building these sewers to remove nitrogen because it's the evil twin. But that evil twin is what you're sucking in every breath you take, to the tune of 78%. The oxygen level normally is 21%, 1% all other gases such as argon, and there's a few others. The oxygen level at 21%, once it goes below 19.5, you're going to be unconscious. So it's a very short range, and wastewater consumes a tremendous amount of oxygen, all right? So you usually can have an oxygen-deficient atmosphere in a manhole. This I showed you before. This was just a Mashpee neck main, and by the way, that concluded my little presentation on the anatomy of a manhole. There was one, and I do have to say this, my wife's going to kill me if she ever watches this, but nonetheless, there was one slide, and I'm not going to go back to put you through it. But when I showed you the manhole top that had brick and mortar around it, there were 2 little yellow things on the side of the manhole. Well, when I put a presentation together, it takes a long time. Sometimes it's days. And I usually run it through with my wife because she gives me good pointers and advice, all right? When I did that last night at 11:30, I brought that slide up and she says, "Wow, that's huge." And I said, "What?" She said, "That thing, it's huge. And they're so small." I said, "What are you talking about?" I said, "It's a normal manhole cover, you know?" She says, "No, the guy's standing beside it." I said, "They're not guys, they're leaves," you know? But it was late. She didn't have her glasses on, you know. But I love her. She's adorable. Okay, so what we have upcoming at the resource facility or the treatment plant, they'll be excavating for the process tanks. So they'll be digging a 3rd big pit, all right? And that's all the tankage where the membrane reactors are going to be. They have to install a fair amount of underground piping. Then they're going to be pouring foundations. You didn't see it in the picture today, but I did take a picture today. They poured concrete in the equalization basins today, and you'll see that on the next shot or on the next progress report. But they'll be pouring the foundation for the process building as well. On the north side, they're going to finish up the CO mains, and then those crews are going to the Route 28 mains. And then on the south side, Simons Narrows next week, they'll be doing some of the services on Simons Narrows. The Mashpee Neck Road main is pretty much done as of today. And then that crew is also going on the Route 28 mains. So they're basically corralling all of their crews to put them on Route 28. So it'll be 2 mainline crews out there, all right, not just one. So my hope is that they're going to be, you know, as expedient as possible to try to get that done. And that was it. Any questions?
Yes, Mr. Jack, I have a couple of questions for you.
Okay.
Okay, one of the things, thank you so much for a very informative presentation. And one of the things that you brought to mind is that there's going to be a need for education for those members of the town who will be connecting to sewer. And although you said that there are things that should not be put into the drains or into the sewer, And it brings to mind that these things are listed in the rules and regulations of the Sewer Commission, and perhaps it would be a good idea at some point in the future to pull these out so that people become educated about what should or could not go into the drains and into the water supply and into the sewers. Would you agree?
Yeah, I think that's a very good idea, and I think probably a good way to do it would be in the form of a brochure that could be handed out and be made available, at town hall and other places. A color brochure, nicely done, professionally done, I think can go a long way toward educating them that, guess what? You now own a sewer at your house, all right? And this is what it means for you. Because there's not only the fog or fats, oils, and grease that people put down there, but there are a lot of other things they put down there they're not supposed to. And it can cause them problems, it can cause the town problems down the road. So it can educate them on those as well.
Would that be something like flushable wipes that may or may not be good to put down the toilet?
Yes, yes. I always recommend, as opposed to putting things in a toilet or down the drain, that as much as possible you try to use, put it in the solid waste, Or if you can recycle it through composting, or some of those are biodegradable, and can be handled that way. But yes, when it comes to actually long-term damage on the sewer, it can cause a lot. And the other thing too, to try to keep in mind, and I haven't gotten to this educational forum on this one yet, is the lift stations. We talked a little bit about them the last time, as to why they're lift stations, but they have pumps and motors, all right? And things like that can get in there and they can clog those devices, all right? So it's not good for a sewer system.
I have another question for you. As you've been talking about the manhole, is there a number of manholes per cubic foot or a linear length of collection pipes that has to be mandated, or how is that determined, the number of manholes for the numbers of pipes or length of pipe?
Okay, other than traditional curves in the road where you're going to make a change in direction, which requires more manholes, generally you always want to try to stay within 300 feet as far as the distance between the manholes to facilitate cleaning. All right, that hose, the further out it goes, the less effective it is, and the harder it is to bring it back. But between manholes, you do want to try to keep about a 300-foot distance.
Can I
Good
ask,
question.
how does each homeowner connect to each pipe as it's going by the house? And maybe this is just a dumb question because this is day one for me, but how does each house hook up to that pipe that's going by their house?
Okay, when I showed the one slide that showed the green main and then had a white fitting on it that had a 90, I think it was a 90, it might have been a 45. But either way, that points to the direction of the house. There'll be another pipe that goes into that. It'll be a 6-inch pipe. Regardless of what the main size, service connections are 6-inch. So the 6-inch pipe would then be extended to the town property line, which is inevitably what people believe is on their lawn. Not really, that's where the property line is. And then they would have to intercept their septic line coming out of the house, wherever it leaves, ahead of the septic tank. You're not allowed to bring it on the other side of the tank. You have to intercept it ahead of it. And so when you intercept that pipe, then they have to navigate to bring it down to that connection that was provided at the street. So at the street level, it's generally going to be 6 to 8 feet deep, all right? And that has to provide a sufficient slope from the house, which is normally a 2% slope, is what they try to maintain, but that's ideal. Could be more or less. But it has to continually slope when it comes out of the house. It has to be continually going down in order to be a gravity sewer. All right, so it can't be a flat pipe. A flat pipe doesn't flow. So even in the sewer mains in the street, you'll start, let's say, at a shallow point, call it 5 feet. At a 1/4 inch per foot for every 4 feet, your main is 1 inch lower than it was 4 feet before it. And it keeps going on and down and down. Eventually you get to a point where you can't go any deeper, let's say 15, 20 feet. That's where you put a lift station to lift it up. Okay?
So if your septic is in your backyard now, and the pipe goes out the back, do you now need to reorient it from the inside, or are you going out the same pipe in the back bypassing the septic and then going around the, just trying to visualize how that would look inside someone's house.
Good point, because both can be true, all right? You can go through the basement if you have one. You can speak with a contractor with the opportunity of, even if it went out the back, you can bring it through the front, all right, most times, or trench around the back, okay, and bring it around the front. Those are really the two options. Okay? Any questions? Thank you.
Okay, thank you very much. If there are no other questions about Mr. Jack's presentation, we can move on to the discussion for the next order of business. And it was essentially to have a discussion of the next phase of the properties to be targeted for getting Line 1 into full capacity. And it would seem to me that we have a bit more homework to be done. And I just want to kind of reiterate where we're going. And I think, Erin, you're joining us, helps us to always give us a chance with a new person coming on board to kind of review where we've been and to think about where we're going. And our overall goal is that we're going to be drawing wastewater from residences, particularly at this point in time, a little over 440 residences, to clean up the water and the watershed and the Mashpee River particularly. So we need to begin to think about how and where we would be going in the next part of and then our next direction. I'm not going to use the word phase because that's been kind of overused. But I'd like to have a little bit of discussion from the commissioners at this point about ideas of what ideas you have at this point. We've tossed around a number of them, but I'd like to hear kind of regrouping at this point.
Meredith, as Catherine, we were suggesting that Al give a brief summary of where we're at so far, and then we could talk about alternatives to go forward.
Okay.
To have the engineers report to us where we are in terms of the volume of collection in the residences that we'll be servicing first? Is that what you mean?
Well,
Actually,
it's basically like we have 120,000 gallons. And so far in Phase 1, Ray, can you tell us the number that we have of that 120,000 that we've already consumed?
Well, there are presently about 300 properties, a little over 300 included. The SRF funding that we had applied for the additional money would have covered the other 100 that were originally in the sewer plan. So if those roads get factored back in, you're up at around 439 properties. The only question then becomes, how do you calculate the flow? And there's different ways to calculate the flow. You can calculate it by Title V. And Title V goes by bedrooms, and it's 120 gallons per day per bedroom on that. And then you have actual flows, which are based on measured flows from the water district, okay? What's the actual usage of the house? Even that's not necessarily that accurate. Why? Because if you're sprinkling your lawn, it's going through the meter, but it didn't go through the sewer, okay? And a lot of times that happens during the season. So it doesn't pick up all of the actual flow. But I would say you're going to be under the 50,000 range with respect to Phase 1. I can say that fairly comfortably.
so Phase 1 flow is estimated at about 150,000
No.
gallons.
No.
No,
We've used up, out of the 120,000, we've used up 50,000.
50,000,
Right.
okay.
right.
So we're looking, we have another 70,000
70 to go.
Right.
Okay.
And if you look back, we've had several iterations of where we were going next. And do you have the projected flow on what these different 2A, 2B, do you have those?
I don't have them right now, but you will have them very shortly. Shortly meaning in a couple of weeks.
And this will be from the engineering report?
Right. For the notice of project change, that's part of their evaluation process for rephasing.
And this report is based on this one?
Yes.
Okay. So we're a little premature if we don't know
Don't have the flow.
what's coming at us to fill the bucket. We will in a couple of weeks, is what you're saying? So
Right, you
I
figure
guess
we're-
what we could talk about is the order of priority of what we think should go in. Is
Right.
that,
Right, for phase, what the engineers are looking at the moment is based on the last deliberative vote that the commission had on what phase 2 should look like, all right? Granted, the original plan had phase 1 through 5, you're building phase 1, but plans 2 through 5 will also change because phase 2, as recommended, includes some areas that were phase 4, phase 5 in that plan, so it's automatically going to change the phasing order of the town. They will have the information with respect to the flows, projected flows for each of those sub areas, A, B, C, D, and F, because E was removed from that. E would have been the other side of town. So they will have actual flow values, estimated flow values for each of those sub areas. With respect to any of the private systems that you may be discussing, for those, we usually have what their flow values are based on their permits, okay? So I can say with a fair amount of certainty, like with wind chime, I know that theirs is, in the wintertime, runs between 10 and 15,000, let's say a day, but then they have a seasonal flow that is going to be higher than that. And I don't recall the actual number of units that they had, but that too becomes an important consideration. So I think moving forward, I would agree it's premature at this point, but I think it's good discussion coming up to the summer months, and I'm going to presume that you'll be able to come to some conclusions before the summer ends and be able to move forward with a final report before the end of the year. That's just my estimate.
Yeah, our sense is that Meredith, that all the commissioners are pretty anxious to move forward with the discussion, but the data is for making any firm decisions is really pending. Calculations, and that, we can state preferences for cost and benefit, and as soon as we can see a result, we'd like to, that kind of thing. But without the calculations, it's kind of premature.
will the engineering report also have, for the private wastewater treatment plants that are in this area, will it have their flows as well as their performance?
Performance standards.
It'll have some information. It's not getting into their performance because it wasn't intended to. Things like that usually become studies unto themselves to begin with. The notice of project change is actually pretty limited in its scope and tasks in that it is going to look at the existing plan that the town had from 2015. It's going to review the proposed 2A, B, C, D, F, its impact, adjust everything accordingly, come up with a value for flows in each of those respective areas. So the sub-areas for Phase 2 will have a flow associated with it. The areas that are remaining throughout the town, they will have flows associated with them as well. So that you can start to figure out what has to go where, all right? So is there another side of town? Yes, there is. Does it have a flow associated with it? Yes, it does. And that phasing will appear in the final plan, all right? So that's the purpose of this, is just to come up with those types of estimates. Going beyond that gets into a whole different level of engineering effort, all right? And it is not including the individual plants. There are a number of individual private plants throughout the town. And they have different types of technologies, and one of these times I may be able to go over some of that with the commission, and various levels of effectiveness, if you will. But there's also a lot of other key points that you will need to have in order to entertain a discussion about them. And I can furnish you with some of that, the engineers can furnish you with some of that, but it's not going to be the level that you're talking about, because if I said we need an engineering evaluation on all the private systems in the town, got to come up with some money. They're not going to do it for free. Okay? They like us, but
Will this engineering report also include a projected cost for each one of these phases?
yes,
Okay,
hold on to your seats.
yeah. I think,
Thank you, Mr. Jack. I think that helps us to get a direction of where we're going. So would it be reasonable to say that, to put on our agenda for the next meeting, is to have the engineering firms associated with the project to give us an idea of what flow values are for projected future possibilities?
I can't commit them definitively for the next meeting, only because I don't want them to be too premature with their numbers. I know they can probably give us some estimated values on these.
Okay.
But as far as actually coming and reporting and being definitive on it, I don't think that they're that far along. The process, the notice of project change that they're working under, started late October, is when the contract was initiated. And then the tasks had timelines associated with them. So by this summer, you're supposed to have a fair amount of that information, and it's supposed to be final by the end of the year. Final at least for reporting purposes, okay? But we're not there yet. That's why I'm trying to be a little bit cautious, only because this is March. Granted, we're ending March, but I didn't want to force them into what normally they wouldn't be doing until June or July, all right, to make it too premature, okay?
just one other question. There had been some talk in the not-too-distant future that we try very hard to include town hall in the phases. And I'm looking at this, and it looks like we're skirting around there. Are the engineers looking at that, or?
The plan that you have is the handwritten document that's got the lines on
Yeah.
it? Yes. The computer-generated document includes town hall,
Okay.
this geographic area here. Because there's going to be a main right there and a main right there, and it wouldn't make
Yeah.
sense not to include this in the middle.
Yes. Okay. I think we
Okay,
await.
so are we ready to then just move forward? And are there any other questions or any other business that any of the commissioners or Mr. Jack that you would like to discuss at this point?
At one point, Mr. Jack, could we perhaps, when they come before us, ask Weston and Sampson or the contract, the oversight, give us some sort of report on construction quality to date?
Sure. My suggestion on that is I wanted to try to keep, for your purposes too, the second meeting of the month would be
Okay.
the best time to do that, okay?
That would be
And I can have them
helpful,
at the next meeting.
just to get an idea of how they're monitoring quality and what issues may have come up.
Sure.
Okay. Thank you.
Right. Thank you.
I guess that's
So
it.
is it possible then to entertain a motion?
I motion that we adjourn the meeting?
And I'd be happy to second that.
Thank you. And again, I apologize for having to be at a meeting with you with Zoom, but that will be coming to an end soon. But thank you all for your cooperation